My dear students, in this video we are going to continue with the stacks. Let us have introduction. A stack is an ordered collection of items where the addition of new items and the removal of existing items always takes place at the same end. This end is commonly referred as the top. The end opposite to top is known as the base. Stacks works on the principle of LIFO, that is last in first out. So always the element which is inserted at the top at the last, so that will go out first. Next, examples. Of course, we have got so many examples in our real life or in our daily lives. We have seen the examples of stacks such as plates kept one on another in a cafeteria. In canteen or in a hotels, you might have seen the plates, after using them, we have kept them one on the top of the other. They are arranged in the form of stacks. One plate is kept on the other, that forms a stack. And in order to remove the plate which is at the bottom, we have to remove all the plates which are on the top of the first plate. Books that are kept on one another. In order to remove any of the book which is below the top, we have to remove the top book first, then we have to take the book which is required. Not only that, even undo mechanism in text editor, normally we are going to press Ctrl Z, means what? We are going to get back to the previous state. Here this uses the stacks. The fourth one is web browser contains back button, because we are going to navigate from one web page to another web page in the website. There you might have seen the navigation bar on the top of web browser, where exactly we have reached in that particular website. In order to come back to the previous state, we are going to use the back button of the browser. Otherwise, we are going to directly use the navigation bar. Next, representation of stacks in memory. So here there are two different methods in which we are going to represent stack in memory. The first one is static representation using arrays, which is fixed in nature. Dynamic representation using linked list, so which is variable in nature. So let us continue with the first one, array representation of a stack. So that is the static structure or a fixed structure. Here you can see in the diagram, here we have got an array that consisting of number of elements, and the subscript starts from 0, 1, 2, 3, so on. And here we can see one pointer called as top. Top is a pointer pointing to null for the first time. Once it is incremented, it points to the 0th location, and next it is point to first location and the second index, and so on. So it is called as stack grows in this direction. Here you can see in the diagram below, for the first time there are 3 elements to be inserted in this particular array, but right now it is empty, and now we are adding one element which goes and settle at the bottom, and second element we want to insert. So we will be able to insert elements from the same end, that is only from one end is called as top end. So from the top we are inserting the second element. In order to remove the first element, we require to remove first second element out, and then we will be able to remove the first element. This is how the stack works. Now let us see the second method, linked list representation of a stack. Linked list consisting of the node. So this particular diagram represents a node that consisting of two parts. The first part is data and the second part is link, or we call it as a reference. So data is the element or data item, that is actual value, which is linked to the other node. Node consisting of two parts. The first one is data part and the second one is address part or link or reference part. Yes, and you can see here it is a null, means what? This is the last node which is not pointing to any other node. Now let us go for how to insert an element into the stack. Here you can see in the diagram, start represent it is a pointer which inserts one node that consisting of data and the reference or link. So this reference or link will be pointed to the other data that consisting of the other reference, or it could be a null. Now we will study how to delete an element from the stack, or you can remove the element from the top of the stack. Here is a diagram that represent start is a pointer which points to the first node that consisting of data and link. This link is attached to the next node that consisting of data and the link, and one more node we have, that is the third node that consisting of data and reference. So here we are going to break the reference between these two nodes in order to delete this particular node. Now let us study operation on stacks. The first operation is stack creates a new stack that is empty. It needs no parameters and return an empty stack. Push item. So here item is a parameter that we have passed to this particular function or operation. So push adds a new item to the top of the stack. It needs the item and returns nothing. Next, pop. Pop is the operation which removes the top item from the stack. It needs no parameter and returns the item. The stack is modified, means it is updated, it is changed, right? Next, peak. It returns the top item from the stack but does not remove it. It needs no parameter. The stack is not modified. Is empty. So it is going to test whether the stack is empty or not. This returns the Boolean value. Next, size. It returns the number of items on the stack. It needs no parameter and returns an integer number. So it returns the how many number of elements are present in a stack. Next, algorithm for push operation. So let us continue with the algorithm. Step 1. If top is equal to n minus 1, here you can say the top is a pointer which is pointing to the highest element, that is the last element, n minus 1. Then the stack is full, so it is going to print stack is full, and then it is going to exit and end of if. Step 2, if it is not true, then this part will get executed. So here top is equal to top plus 1 means what? Earlier it was initialized to top is equal to minus 1, that is pointing to nothing, that is null pointer. If we increment the value of top by 1, it will become 0, because top is equal to minus 1 plus 1 gives me what? Minus 1 plus 1 will get cancelled, top is equal to 0 will come, right? So top is pointing to what? 0th index, that is the first element in the array. Step 3, stack of top is equal to item. So the item that is to be pushed, or the element that is to be pushed at this particular location of stack. And step 4, it is going to return the item. Now it's time to have a programming example to show how the push operation works on stack. For that I will take you to my laptop screen, and this is one of your lab programs. Here we have already write a program to perform push items into the stack. Let us continue with the preprocessor directives, that is hash include iostream.h, next hash include conio.h, then we'll use hash include stdlib.h header file, because this is required because we are going to use one inbuilt function of this particular header file, exit function. So next we'll continue with the hash define, so that is global declaration n, that is 5. Now we'll write void main curly open brace, and here we are going to declare all the variables and the array called stack, and here in a square bracket we are going to write capital N. Next variable is I, el is element. Next we'll write top is equal to minus 1, So that is indicated, it is pointing to the null pointer. Next we have got choice is equal to 1. So 1 represent here, it is always true. Now here we'll use CLR SCR function, and then we'll use while looping structure, and in while we are going to write choice. Choice is equal to 1, hence this enters into infinite number of times. It is going to iterate certain set of statements which are declared within this while loop statement. So here let us write cout and in a double quotation mark /n, and here I'm going to write stack operations, and we'll use /n and /n, so in order to provide the space in between, and then we'll continue here only as number 1, so that is used for pushing the items. So here we'll write push /n, it has come down to the next line, and then we'll write 2, and here it has to display the content /n, and the third one is exit, so it must terminate. Here /n and then put semicolon. Now we are going to write cout /n, and here we'll write enter your choice. Then we'll use scene choice. Switch statement we are going to use. Switch is a keyword, and inside this switch statement we'll use choice as expression. Next we'll use case label 1 and then colon. Here we'll write cout, enter the element to be pushed. Here we'll take scene element that is to be pushed. Now we'll use the condition if top is equal to n minus 1, then it is full, correct? Is curly open brace. Here we are going to display the information to the end user as stack is full. Now we'll write get ch, it should take at least one character, and then it has to exit. So this particular function is present in stdlib.h header file. So next put semicolon, then curly closing brace, and we are going to write else part, and in else part we are going to write statements such as cout in a double quotation mark. Before that we'll write here element that is to be inserted is inserted at position, correct? So here we are going to write top is equal to, otherwise we'll say top is equal to top plus 1, otherwise we'll say top plus 1, or else we'll write top plus plus. Okay, next here we will write top plus plus. Next stack of top is equal to element is to be inserted at this particular point. Next we'll write here break statement. Then we'll go to case 2. Let us case 2 colon, and here we will write cout content of stack is, and then colon /n, and I want to display all the elements which are present in the stack. So here we'll write if top is equal to -1, then it is empty, correct? Yes, here we will display the information such as stack is empty. Otherwise we'll write here get ch. It has to take one character at least, and then we'll use else part. So for this also we are going to use curly open brace, and for this also curly closing brace, and then we'll use else part. And here we are going to write the looping structure for I is equal to top, then I is greater than or equal to 0, and I minus minus, because we'll have to come from the top of the stack. Yes, here we'll write cout in a double quotation mark. We're going to write stack, and in a square bracket we are going to write the value of I. So you can use insertion operator, and here we'll use I, and again use insertion operator and put in a double quotation mark so that it can print as it is, that is square bracket and equal to sign. And here again insertion operator, and here we'll write the value stored in stack of ith position. Here we'll use yandel. Okay, fine. So here we'll write next break statement, curly closing brace. Here you can use curly open brace, curly closing brace for this else part. And now we'll write case 3, and in case 3 we are going to use the function exit, which is present in stdlib.h header file. Now we'll use break statement in order to come out of this particular case label, and then we have got at the end default statement has to execute. So default cout invalid choice. So curly closing brace for this switch statement, and curly closing brace for while loop, and here we are going to use get ch, and here one more curly closing brace for closing main function. Now let us compile this program, and here you can see there is error. So let us check. Okay, it should be double equal to sign. Again compile, errors, so possibility incorrect assignment. So here again take double equal to sign and compile, errors, so compound statement is missing here. Just check it out where exactly we left out. So this else part has to get closed. Okay, fine. Again click on compile, success, there is no error. Click on run. Now you can see here, so stack operations, the first operation is push, second operation is display, and the third operation is exit. So let us first display. For the first time it should be empty, correct? Yes, here you can see the content of stack is empty because we have not yet pushed any element. Again click on run. Here you can see nowadays asking us to, you can press 1 to push, 2 to display, and 3 to exit. Now we are going to press 1 to push the element, enter the element to be pushed. So now I'm going to enter 10. So you can see here 10 is inserted at 0, means it is the index number 0. So again I want to push one more element. Again I'm going to press choice 1. Now I want to insert 20. You can see 20 is inserted at 1. Now again I'm going to press 1. Here the element to be pushed is 30. Here you can see 30 is inserted at 2. Now again I'm going to press 1, and next is 40. So 4 elements we have already inserted. The 40th is inserted at position 3 now. Again I'm going to insert one more element, so that is 50. So this should be the last element. After this it has to show that the stack is full. Let us press the choice as 1 again, and now we'll try to enter 60. So here you can see stack is full. Here once again we will run this program, and we are going to push the elements 1, 10, 1 again, next element is 20, 1 again, 30, 1 again, next 40, 1 again, next 50. And now I want to display all the elements which are pushed into the stack by pressing 2. So here you can see stack 0 consisting of 10, stack of 1 consisting of 20, stack of 2 consisting of 30, and stack of 3 consisting of 40, and stack of 4 consisting of 50. Now we want to exit. You can press 3 to exit. Next, algorithm for pop operation. Step 1, if top is equal to null, so that is if it is top is equal to -1, if it is pointing to null, then it is going to print stack is empty, exit, and end of if. If this is false, then we are going to have the elements in the stack that is to be removed or popped out of the stack. This is initialized to item means what? We are removing one particular data item of this particular top position from the stack and initialized to item, and by decrementing the value of top by 1. So top is equal to top -1. Why top -1? Because the pointer always by default points to the last element in the stack. Once one element is removed from the stack, the pointer will get down to the next level, which is below the level of the previous one. And next is step 4, that is it is going to return the updated stack. And now this is the time to go for a programming example, how to pop out or how to remove the item from the stack. For that I will take you to my laptop screen, and this is also one of the lab programs. Here we will write a single line command as write a program to pop the elements from the stack. Hash include iostream.h header file, hash include conio.h header file, hash include, here we are going to write stdlib.h header file. So that is standard library.h header file that consisting of one inbuilt function called exit. Next, let us define the global variable hash define capital N and 5. Here we'll write void main curly open brace. We are going to declare all the variables including stack array, and inside the square bracket we are going to write capital N. So that takes the value from the global variable hash define N5. So here we are going to initialize this array with assignment operator and all the 5 elements. So here we will write 10, 20, 30, 40, 50. Next put semicolon and declare all other variables. So one variable called choice is equal to 1. 1 represent it is always true, and element that is to be popped out ELE top is equal to 4. So here the 4 is the index number, top is a pointer pointing to the last index that consisting of the element 50. Now let us write CLR SCR function. Then we are going to use looping structure while, and inside the round braces as expression we are going to write choice curly open brace cout, and here we are going to create the menu for the end user. Here we will write stack operations, and then we'll use /n, and here we will write the first menu, that is pop /n, and the second menu should be display. Here we'll write capital P, yes, okay. Next /n, and then the third one should be exit. Here we'll use /n, and now we are asking the user to enter their choice. Enter your choice. Now we will use scene, and here we will use choice. Next we are going to use a switch statement. In a switch expression also we are going to use choice, because user may select either 1, that is pop, 2 display, or 3 exit. So let us continue with the first case number 1. and then if here we will write top is equal to -1. If it is true, then cout, it should display that the stack should be empty. So stack is empty. Now we'll put get ch, then we are going to write exit function. So this particular function is present in standard library.h header file. Then put curly closing brace and then use else part and curly open brace, and here we are going to use for looping structure because we'll start pointing from the last element. So that is int I is equal to top, and then I is greater than or equal to 0, then I minus minus. So next element is equal to stack, and here in a square bracket we are going to write top. So from the top it has to pop out. Next cout, the information is the popped element is, here we are going to write the element which is popped out. Next we'll write top minus minus, and then we are going to use break statement, curly closing brace for this else part. Next we'll move on to case 2 colon, if top is equal to -1, then it should display cout stack is empty. Next get ch and exit function, then curly closing brace, otherwise else part curly open brace. Here we are going to write cout, it should display the content. Yes, if the user presses the second option, then it should display the content of stack is /n, then it should display all the elements. So using for loop, for I is equal to here we'll write top, and then I is greater than or equal to 0, then I minus minus. So it has to display all the elements from the top. So cout, and here in a double quotation mark we will write stack, and then we will use square bracket, and here it should display the value. So using insertion operator, then I want to display the closing square bracket and equal to symbol, and it should display the value stored in stack of ith element, and we'll use endl statement. Now we'll write break statement and then put curly closing brace to close this else block. Now we'll go for case number 3. So here we have to exit out. Next, if the user enters any other number other than 1, 2 and 3, then the default statement has to get executes. So here we will write cout, and in a double quotation mark we'll write invalid choice. Curly closing brace for switch statement, and this is for while loop, and here we'll write get ch, and then we are going to write closing curly braces for main function. Now let us compile this program, and here we'll see one error. So here it is not defined, let us define it as int. Next again compile, here it is success, so click on run, and here you can see it is displaying the menu. The first one is pop, second one is display, and the third one is exit. So let us see all the elements are initialized or not by pressing 2. Here you can see stack of 0 consisting of 10, stack of 1 consisting of 20, stack of 2 consisting of 30, stack of 3 consisting of 40, and stack of 4 consisting of 50. Now we want to pop out the first element from the top, that is 50. So let us press 1 to pop out. Here you can see the popped element is 50. Now I'm going to press 2 to display. Here you can see 50 is popped out, only 10, 20, 30, 40 is present. Again I'm going to press 1 to pop out 40. Next you can see display and 10, 20, 30 is present. Again I'm going to pop out 30. You can see here 30 is popped out and we will remain with 10, 20. Now I want to pop out 20, press 1. Here you can see 20 is popped out. Display, and here you can see stack of 0 is equal to 10. That is the last element. Let me press 1 to pop out, that is 10 to pop out from the stack. Now 10 is also popped out. Now it should display the stack is empty. If I press 2, here you can see stack is empty. That's all in this video. Thank you very much for watching this video. We will see you in the next video.